So my name is Emma Spiro. I'm a sociologist at UC Irvine. Today I'm going to talk about what we call rumoring during extreme events. So this is a case study we did in informal online communication in the context of the 2010 Deepwater Horizon oil spill. So I'd like to acknowledge our supporters for this, NSF and ONR. Also, my collaborators, Jeanette Sutton and Matt Gretchek, are at the Trauma Health and Hazard Center at UC Colorado Springs. Also, Sean, Nicole, and Carter, who are with me at UC Irvine. So this comes out of a larger project that, as you saw on the title slide, is called the Heroic Project, Hazards, Emergency Response, and Informal Online Communication. So let's start at the beginning. I'm a sociologist. I'm interested in human behavior and how humans behave. And we know that the informal exchange of information, mundane activities such as gossip or rumor or casual conversation, are characteristic human behaviors. And in the context of disasters, there's been a lot of work that looks at how people exchange information in this context of imminent hazards or extreme things that are going on in the environment. So we know that actors in a crisis situation or setting use their social ties to obtain factual information regarding these imminent hazards or events that are going on. And we know that some of these informal social ties are actually the primary means by which people obtain time-sensitive information, and this is especially the case in contexts where official sources might be slow to release updates. So this provides us sort of a theoretical background and motivation for the problem and the research question we're looking at. Now let's take this into the context of social media and online social communication technologies. We know that they're becoming widely used. I don't need to argue that for this audience, but they're also being used within the context of emergency response. And one of the reasons why some people, practitioners in this area, have recognized the potential of some of these technologies is because they can be used to collect and disseminate disaster-related information. They can be used for sort of collective sense-making processes, and they allow individuals to reach a much larger number of others who are distributed across greater distances than previously possible. So a lot of work that was done in this area looked at very localized disasters. They looked at word-of-mouth communication between individuals, and now we've sort of moved this to a global scale. So despite all of these things here, there's relatively little that is known about the dynamics of informal online communication, especially in the case of response to extreme events that are going on in the environment. So this is the motivating research question for this project in general, and what I'm going to talk about today, a specific piece of it. So I said I was going to talk about rumoring, and now I'm talking about all these things in forms of informal online communication. What do I actually mean by rumoring? So we take a very broad approach. There's been a lot of research and a lot of literature within sociology and social psychology that tries to define rumoring. They distinguish between rumoring and gossip and all these kinds of things. But we're going to take sort of a basic, broad approach in what we define as rumoring. So we say that rumoring is any communication surrounding facts or events of topical interest that does not occur as part of the formal process, institutionalized process. So this is contrasting some of the information exchange that goes on, say, on social media or Twitter, what I'm going to talk about today, with official news broadcasts, warnings and alerts that come out of emergency management organizations, and official press briefings and things like that. So I'm kind of going to use online informal communication and rumoring synonymously here. So let's turn back to some of the theory that comes out of social sciences, in particular social psychology and sociology. There's been a lot of work on what determines the extent of rumoring. So what determines what information is actually going to go viral or spread in a specific environment. So some of the classic work in this area was by Allport and Poston. Maybe some of you in this room are familiar with this work. They have a classic sort of study. It's more of almost a demonstration during one of their lectures, but they show an image on screen and they ask people, essentially like the telephone game. They show one person the image, then they ask them to describe that to another person, and that person has to come in and describe the image and so on. But they talk about, in their article, they identify 3 important features that have sort of stuck with this body of work and been important in determining how people think about the factors or features that influence information exchange and rumoring. So the first here is the perceived importance of the information shared. So that might be relatively obvious for some of us. Another thing they identify is the degree of cognitive unclarity surrounding the information. So this might be, how uncertain are we about the information? Are there conflicting reports about what's going on? All of these two things increase people's propensity to share information or exchange information or rumor about something. And third, the suggested behavioral change resulting from the information. So is what I receive going to immediately or have the potential to immediately impact what I might do? And we'll talk a bit about this more in the context that we're going to look at today, Deepwater Horizon. There's been some other interesting work that looks at how anxiety levels change rumor activity. So if there's increased anxiety among the population, it may or may not be due to the information or event that's going on. That increases people's chance of passing along information. And one argument that I'm going to talk about in particular today is Kaplow argued that the presence of official information tends to suppress rumoring. So this is sort of an information substitution theory, where if we have official sources of information, there's no need for us to rumor about these informal things because we have this other source of information coming in. So what we're going to do today is look at the context of informal communication online. In particular, we're going to collect data from Twitter, and we're going to look to see how some of these theories speak to what's going on. Can we apply these same theories that were formulated and tested in a face-to-face setting to this online informal communication? All right, so I probably don't need this slide, but let me just go over some of the specifics of Twitter for those who might not be as familiar. So we know Twitter is a really popular microblogging service. People exchange short messages on the site, and they communicate with each other in various different ways. They maintain directed social relationships, which automates the exchange of information. And it's particularly well suited for what I'm going to talk about today, for us to study informal online communication, because it's publicly available, it's well suited for rapid information dissemination, and it's not part of this institutionalized process. So let's back up a little bit. Let me talk about the case study for a second for people who might not be familiar with Deepwater Horizon. It's been a few years now since this event occurred. April 2010, explosion on the Deepwater Horizon offshore drilling rig, killed some crewmen and resulted in a massive oil spill. So one of the biggest oil spills in the history of the petroleum industry. It affected wildlife in the area. A lot of area in the Gulf of Mexico was closed to fishing. It affected tourism. It affected a bunch of different things in the area. So we want to study this event, and we collect data from two different periods, a 10-week period immediately following the event. So once it was sort of recognized that this was going to be a significant national disaster, and then an 8-week period, the sort of the post-event long-term effects of the disaster and recovery events that were going on. So we collect data from Twitter. For those of you who have used Twitter before or collected data, you know it's kind of a pain in the butt. So we use the search API, and there's a lot of different ways to collect data on Twitter, but we want to be very sure that we know exactly what data we're getting, exactly where we have missing data, and so that we have a principled sample of tweets and conversation that is going on. So we use a keyword-based approach, similar actually to the previous presentation. So we start with a list of keywords. These are keywords related to the disaster event that's going on, things like oil spill, Deepwater Horizon, natural disaster, BP, things like that. We also compare this with a list of what we call control keywords. So these are just keywords chosen at random from Ogden's Basic English Core Word List. This is going to provide us with sort of a baseline sample to compare against. So our goal here is to capture all public tweets that contain this given set of keywords. Now, obviously, that's a sort of lofty goal. It doesn't actually happen, but we get pretty close. So Twitter imposes unpublished query rates on their search API. And so if you try to collect too much information, basically you get shut off. So we have an adaptive query scheme that tries to maximize the time between queries that we make, but minimize the amount of missing data we have. And the good thing for us is that this is a very principled scheme because we know exactly when we have missing data. And in addition, the strategy allows us to accurately estimate, say, hourly rates of usage, which is really the outcome we're interested in here. So even if we don't collect everything in a specific bin, we know a small amount of information there. We can estimate the hourly rate in that time period. So a quick overview of some of our data here. You can see our two different keyword groups. disaster-related or Deepwater Horizon specific related keywords at the top there and some of our control keywords at the bottom. This gives you an idea of the scale of our data and what we're looking at here. We do see variability in the average hourly rate that these terms are used, so some of them are used a lot more than others for various reasons. The character length is restricted here, so people might not want to use long phrases like environmental disaster. Things like BP are short, they can stick it in there. All right, so the method that we're going to use here is relatively simple. Pretty straightforward. This fits within a very standard time series modeling framework. So we have a response here, which is the frequency with which posts using topic relevant, by here I mean Deepwater Horizon relevant terms, appear within the broader stream of conversation or posts that are going on. So we take a really simple approach here and just estimate a latent factor model for all these different topic-related keywords. So we take our multiple time series streams here, one for each keyword, and we estimate a factor model of them. So at the end of the day, we have one outcome here that's a time series over time of sort of the joint variability of this topic-related conversation. We do the same thing with our control keywords and use this as a predictor of the hazard-related conversation because we want to control for, say, the baseline tendency of people to use things on Twitter. Maybe Twitter is growing over time, so there's an increased conversation over time. We use these control keywords to control for that. All right, so let's come back to the theory a little bit and talk about what factors we might want to test as affecting rumoring. So obviously, when we talk about conversation in general, one of the things that immediately comes up is seasonality. We know that conversation varies by hour of day of week, all these kinds of things. So we control for all those basic seasonality terms here. And we come back to our determinants of rumoring that come out of the social psychology literature. We can talk about formulating some predictors here that capture some of these ideas. So we want to look at media coverage. We know that Kaplow predicted this sort of information substitution idea. So we draw off three different sources of media coverage. Official press releases, so these are things that come out of the Deepwater Horizon Joint Information Command Center. We look at newspaper articles. So we use LexisNexis to look at the top major national newspaper articles that contain the same keywords that we're using for our Twitter collection. We also look at Wikipedia. So this is more of a publicly input news site, we might say. So we look at the attention that's paid to the Deepwater Horizon page on Wikipedia, both in terms of page views, but also page edits. So we also want to look at wildlife impact. So this kind of gets at the importance of the information and also the relevance to behavior that I talked about previously. So we use statistics from Fish and Game to look at how many birds, turtles, reptiles, mammals were collected and released in the Gulf of Mexico during this time. And another thing that we're going to look at here is fishery closure. So I mentioned at the beginning that large areas of the Gulf were closed during this period to fishing. So this impacted the local economy in a very drastic way, and tourism and all these kinds of things. So as a quick example, to show you sort of the scale of what's going on here, this is for one day, June 21st, 2010. Everything within this red line here was closed to fishing in the area. So this is a massive scale. It's sort of, a large proportion of the Gulf Coast was closed. And we also want to look at, as I talked about previously, sort of this degree of cognitive unclarity, severity of the event that's going on. So we look at, there were many different estimates of the oil flow that was actually coming out of the break during this time. So there's multiple different estimates that allows us to estimate not only the severity, but also the uncertainty in what's going on. So all these different things are going to inform our model of the online informal communication. So we stick them in here. Sort of standard modeling selection procedures. We use the AICC to evaluate each of these candidate models. We do an exhaustive search with all these different covariates, and here's what comes out. So on the right here, we see a null model. If we're just going to control for the autoregressive term here, intercept, trend, and our control time series, this is our control keywords, remember, we see this null model just as a comparison. And I'm going to show the top two models here, but just really talk about the top model. So we see some interesting things right off the beginning. Obviously, the autoregressive term is significant here. We do see a slight trend, negative trend. So as time goes on, less and less conversation is going on about the Deepwater Horizon oil spill. This is sort of intuitive and as expected. We see a few of our different covariates of interest here are chosen to be in the top model. In particular, I want to highlight these two in the time that I have to talk today. So we see that the log number of news articles published, this is from our LexisNexis data, has a significant positive association with the informal online communication. We see the same is true for the water area closed in the Gulf. So what do these results say? We see that media coverage is positively associated with rumoring behavior. This supports these ideas of information or importance or saliency theories, so the perceived importance of the event as all port and postman originally discussed. And it disconfirms, in this case of the Deepwater Horizon, some of these ideas about information substitution. So we don't see that official sources of information actually suppress rumoring behavior. We see just the opposite. And as I talked about before, the water area closed in the Gulf is also associated with increased conversation levels. So this might speak to some of these relevance to decision-making behavior as being influential. So when a large amount of the Gulf is closed, it really impacts people's livelihoods. They can't go out and fish anymore. People are less likely to go in the water and go swimming. So it directly impacts their behavior. So these are the two things that sort of come out of our analysis here that turn out to be particularly important in the ongoing context in the case of Deepwater Horizon. So let me talk about one other portion of our analysis, and that has to do with serial transmission. So for those of you who might be familiar with the literature on rumor or less familiar, we know that one of the important features of information exchange is that people pass along information. That's how things go viral. That's how rumors spread. So there's been substantial attention paid in this literature to the process by which this happens. So what impacts people's chance to pass things along, and how does that process work? So this idea of serial transmission is really vital to rumoring behavior. And on Twitter, one of the interesting things is that it's really built into the system. It's built into the infrastructure to promote serial transmission of information. And we all know this as retweeting. So what is the relationship we want to look at here between comparing information that is about the Deepwater Horizon or contains keywords that might be relevant to Deepwater Horizon with our control? So two things pop out here for us. And one, if we look at the ratio of original posts to retweets over time, and we compare this between oil spill content and control content. So you can see a clear difference here at the top. This is oil spill related content, and on the bottom is control related content. So the oil spill, if we think about the stream of tweets that's coming out that are oil spill related content, we see the stream contains a much larger proportion of retweets. So perhaps this suggests that people are passing along information about the disaster in this environment on Twitter. We also see really clear differences here in terms of if we say, look at the content and the chance that messages get retweeted. So on the x-axis here, we just the retweet probability, what's the chance that an average message that contains this keyword is retweeted? And given that it's retweeted, how many times is that original message retweeted? So what we see here is there's a very, very clear difference in oil spill related content on the right and our control keywords on the left. So messages on Twitter that contain these oil spill related keywords are much more likely to be retweeted than our control content. But we don't see a really clear difference in the actual number of times that they get retweeted. All right, so what do we see as sort of summary of our results of this investigation of serial transmission here? We do see differences in retweeting observed across the different keywords that we're interested in. We see that our oil spill keywords are more likely to be retweeted, but there's not really a huge difference in the number of times that things get retweeted, given that they are retweeted at least once. So in summary, what we're doing here is testing some of the classical theories of rumoring or determinants of rumoring in the context of informal communication online. We see that media coverage of the event is strongly associated with increased rumoring online. We see that this speaks to importance and saliency. We have sort of disconfirmed the presence of information substitution in this case. We see that relevance to decision-making behavior is also important, seems to be important as an influential predictor of online conversation levels. And we also see this clear difference in terms of serial transmission and the rate of serial transmission based on the content of that message. And this is not really surprising. There's been a lot of work that looks at what are the features that influence retweeting. So in conclusion, online communication media are readily used in the context of extreme events, and we want to study the dynamics of that conversation, what's going on, why people are talking about things, and what they're talking about. And it's really helpful, we find, to bring back in some of these original theories of rumor behavior in the context of disaster events. So the rumor-related behavior online is really driven by a lot of the same mechanisms that we see in face-to-face or other behavioral settings. So that's really interesting for us, and we continue to work on this problem in a lot of different areas. So thank you. I think I have time for a few questions.